Welcome to our guide to wireless or Wi-Fi networking, an essential part of the infrastructure of almost every business. Now, although wireless is very popular in the home environment, keeping wires to a minimum and allowing tablet, laptop and smartphone access from anywhere inside or even the garden. For a business, wireless offers vital flexibility and increased productivity for certain functions. However, it shouldn't be overused due to the additional management complexity and the vulnerabilities it also presents. Wireless connectivity is simply an extension of the wired LAN of switches and routers to enable mobile devices to have the same network access as regular desktop PCs and workstations. The three main factors to consider when using wireless is coverage, connection speed and resiliency. Where wireless coverage is concerned, it's essential that the area covered by a wireless signal is strong enough to provide sufficiently fast data access for all the devices that need it. This may involve using numerous access points to ensure the coverage is consistent and without dead spots. If your wireless users just access email and small files, then it may be that many devices can connect to just a couple of access points spread out across an office floor. If they're doing video calls and working on large multimedia files, you may find that many more access points are required. Another consideration is mobility. For example, if your users are moving between floors and meeting rooms, then a sufficient number of access points will be needed to allow handover between the rooms to ensure that the signal isn't interrupted. And it's for this reason that a site survey is recommended before deploying a wireless network to ensure that you get the correct coverage and signal strength everywhere that you're going to need it. Much like wired networking technology, there are several speeds of wireless available, each not only providing greater bandwidth, but also covering a greater distance and a wider range too. To get the optimum performance, the wireless NIC in your mobile device must be the same standard as the access points. The various standards are backwards compatible, so you'll always be able to connect, just at a slower speed if you're using an older NIC. The wireless standards are all called 802.11 with the following letter or letters to denote the speed. The first standard was 802.11b, offering connection speeds of up to 11 megabits per second. As of autumn 2022, the latest standard is called 802.11ax and provides up to 4,804 megabits per second. The speeds are either delivered in the more common 2.4 GHz bandwidth spectrum or the lesser used 5 and 6 GHz bandwidth spectrums. And the reason for the use of higher frequencies was to get around some of the unavoidable interferences and reduce connections in the 2.4 GHz space, as this is where many other devices operate, such as other radios and microwaves. It's worth noting here though that the wireless throughput speeds given are only theoretical maximums. The demands of multiple users, other wireless interference and obstructions will likely result in the actual connection speed being much lower. And this is another reason to only use wireless connectivity where absolutely necessary, as wired infrastructure is not prone to these levels of interference and performance drop-offs. Using dual or tri-band access points offers the most basic form of wireless network segregation, in that low demand users can be placed into the 2.4 GHz spectrum, whereas high demand users can be allocated connection in the 5 or 6 GHz spectrum, where there's less peripheral noise, making the connections of higher quality overall. And much like across a wired network, the more users that are connected, the more management of the traffic data is required. This can be achieved within network switches using functions such as quality of service, known as QoS, and virtual LANs, also known as VLANs, where users can be segregated and prioritised by either their team, their workload or their status. These QoS and VLAN capabilities can be mirrored out to the wireless infrastructure too, so regardless of how and where a user connects, their rules and policies remain consistent. The more complex a wireless infrastructure gets, the more management it needs, and bandwidth spectrum segregation and techniques such as QoS and VLANs that I've just mentioned will only go so far. These parameters are only as good as the consistency of coverage that can be provided, and coverage can be easily interrupted by hacking attempts, access point failure, unforeseen interference or even substandard extension of the wireless coverage. As mentioned earlier, a site survey is always a good idea when deploying a new wireless network. but it should also be considered when extending an existing one. If you imagine a U-shaped office, numerous access points would be needed to give good enough coverage, although as you can see, there may still be dead spots near the edges of the building. In this diagram, if you wanted to cover the area to the left, which is not currently covered, you could use a repeater to avoid having to cable in another access point. However, the repeater needs to be placed in the first access point's coverage area, and then the repeating signal is halved, so the new area would receive a weaker signal. Ideally, you should mirror the other half of the office and deploy a full access point to make the coverage and signal equal throughout. When you end up with multiple access points like this, the downside is that they all need managing. You can apply all your QoS, VLAN and bandwidth spectrum rules across each one, but you will need to do this separately. So the more access points you have, the more admins required. An alternative to this is a managed wireless infrastructure that uses a central controller to connect one master access point. Then all the others connect wirelessly to this one, creating a mesh across the office floor. This not only simplifies management, as all rules are cascaded to each access point in a single action, but the resulting coverage is much stronger and more consistent. And of course, this means less cabling is required too. It also means that should one access point fail or incur interference, this is detected by the management software and signals can be boosted on all other access points dynamically to alleviate the issue. It's also worth mentioning that however you connect access points, either individually or using a master and mesh system, you can take advantage of Power over Ethernet, also referred to as PoE. PoE means that any physically connected access point can receive its power through the Ethernet cable, so a separate power supply and wall socket is not needed. And this not only reduces cabling, but also makes it possible to locate them in the optimum position. So there you have it. Hopefully you've now got a good grasp of business wireless networks, their components, elements and functionalities. I do hope that you found this video useful, though if you do have any questions or feedback, please pop them in the comments section below and our network experts will reply to you.